So we're going to use Gauss-Jordan. And we're going to rewrite this in what's called a matrix. Because Gauss-Jordan uses a matrix. We'll talk about what that is here in just a moment. 36, we have a minus z equals 6. And then we've got x plus z equals -1. Okay, so this is a system, and we're going to solve this with Gauss-Jordan. Okay, so when we look at using Gauss-Jordan, we replace everything with a number instead of the variable. And we put it in what's called a matrix. And so we don't use the variables because sometimes it's easier to not look at them. We just put them in a matrix, and we want the numbers in front. And if there's no number, we'll put a 1. So like, for example, the y and the z, if there's no numbers, we put a 1. Now, we're not worried about the variables. We just want the numbers. And we've got our 3 rows here. So the first row. Now, if you're missing a part, you plug in a 0. So on the first one, we have a minus x, so that's a -1. That goes here. We have 1y on the first one. Do we have any z's? No. So we plug in a 0. Now, this vertical line that represents the equal sign, and what's on the other side? -1, right? Make sure we copy it down correctly because it's so easy to make a mistake with these. And just simply copying something down wrong, the whole thing will be off in there. So be very, very careful with your algebra. On the next row, okay, the next one, do we have any x's? No, so that's 0. What's my y? Y is a 1. And then we've got a -1. And then the other side is a 6. Next row. Next row we have 1x, we have no y's, we have 1z, and it equals a -1. Is everyone okay with how I built that up? Now, what we want is we want to create a whole bunch of zeros. We want as many zeros as possible. We want basically a number here and then zeros below, and then same thing here, 0 and 0, 0 and 0, until we can get something that we can back substitute. I'm not going to make you do complete Gauss-Jordan elimination. We'll do what I have you do is Gauss-Jordan with back substitution because it's easier. So let's try to create a 0 right here. Okay? Now, what I can do is I can add rows together. So what would happen if I took the first row and I added it to the second row? What would happen if I add this to that? That's a 0, and that's what I want. Okay, now you do one row at a time. So the first row and second row, they get copied. So the first row is -1, 1, 0, -1. And then we have 0, 1, -1, and 6. Now the last row, we're going to take this top row here and we're going to add it to the third row. So we're going to add these together and put it down here. So -1 and 1, that makes it a 0. 1 and 0, that makes it a 1. Okay, 0 and 1, that makes it a 1. Those add together. -1 and -1 makes it a -2. Is everyone okay with that? Now, we're on the right track. What I want to now do is I want to get it where I have basically zeros in a row, except for one number. So let's work here. Let's try to make a 0 here. Okay. Now, do not use the first one, because if I add down, what's going to happen? it's going to cancel out those zeros, right? We don't want that. We want to keep these zeros here. So let's take the middle row and let's multiply it by a minus 1. So I'm going to use a minus 1 for the middle row. I'm going to show you why I'm doing that in just a moment. So take the middle row. You only do one row at a time. If you go on into mathematics, you're going to take courses in nothing but matrix algebra. This is matrix or linear algebra. But in this class, it's just kind of an introduction. So we keep the top row the same. And the middle row, we're going to multiply by a minus 1. So when I multiply the middle row by a minus 1, minus 1 times 0 is still a 0. Minus 1 times 1, that's a minus 1. Okay, minus 1 times a minus 1, that makes it a positive 1. And minus 1 times 6, that's a negative 6. Okay, keep the bottom row the same. You only do one row at a time until you get really good at these. Now, why did I do that? I did that because, look now, if I take the middle row and I add it to the bottom row, what is that going to create now? That's going to create a 0, and that's what I want. And then we'll be able to use back substitution to get the final answer, the ordered triplet. I don't make you do the complete Gauss-Jordan because Gauss-Jordan is where you have zeros everywhere but on the diagonal. And that just takes way too much time. I teach Gauss-Jordan with substitution. So now when I add down, what's going to happen? Okay, we always only do one row at a time. Very important, only one row. So the top row is going to stay the same. Middle row stays the same. Bottom row, we're going to add down. Okay, 0 plus 0, that stays at 0. Negative 1 plus 1, that makes it a 0. 1 plus 1, that makes it a 2. Minus 6 plus minus 2 makes it a minus 8. Is everyone okay with that? Now, look at what we've got. Those are both zeros. This is x, y, and z. So this row, if I write it out, what is it? As an equation. This bottom row is actually, we have no x's, no y's, that is 2z equals now what? Negative 8, doesn't it? Can I solve it for z? Yeah, divide by 2, and so z now equals a what? Negative 4. Now, once we have one piece, then we just do like we did before, and we start working back up. Now let's look at our second row. What is the second row? As an equation. Just work your way up. Row number 2. Well, what's row number 2? Minus y plus z equals what? Minus 6. Well, what do we know? Do we know one of the missing variables? Yes. Which variable do we know? Z. What is it? Minus 4. So that's minus y minus 4 equals a minus 6. We can now find out the y by adding 4 to each side. And we've got minus y equals now a minus 2. Okay. Divide by a negative 1, and that gives you y equals now what? 2. Now, how do we get the last one? Go up to the top row. What's the top row? As an equation. Well, row number 3, what is it? It is, if I read it, minus x plus y equals what? Negative 1, doesn't it? Well, do we know enough to find that missing part? Do we know enough now to find our x? Yes, because what do we know? We know that y is what? 2. So that is minus x plus 2 equals minus 1. move that minus 2 over. So minus x equals now, when I move it over, minus 3. Okay, so that's going to be our minus 3 there. We divide by a minus 1. And what does that give you the value of x to be? 3, doesn't it? How do we write our answer? And our answer as an ordered triplet is x, y, and z. Yep, thank you. I was going to close it, but thank you. And what would that be as an ordered triplet? As an ordered triplet, that would be 3 for the x, 2 for the y, and minus 4 for the z. Now, I'm not going to give you anything this complicated on your exam. On your final, you're only going to have 2 variables and 2 unknowns, or sorry, 2 equations and 2 variables, 2 unknowns. And you can solve it however you want. Substitution, elimination. We're going to learn today Cramer's rule. On the final, 2 variables, 2 equations. That's it. I'm not going to give you 3. Because they just take too long and they're so easy to make a mistake. 1 sign error and the whole thing is done. That finishes up 5, 1, and 2. Because this is like question number 10 in the homework. Right? So what we just did, this is very, very similar to question 10 in the homework. So just so you know, that's going to be, this one was just like question 10 in your homework. Now we're going to move on and we're going to talk about determinants today. And hopefully we can get through this homework. If not, we'll finish it on Tuesday. The other class did, but just barely. So if we don't finish all of it, then we'll finish some of it on Tuesday. So we'll see how far we get. So we're going to now move on, and we're now going to look at 5.3. And in 5.3, we're going to be looking at determinants, and Cramer's rule. And that's a C there. So that's a C. Not a G, that's a C. So we're going to look at Cramer's rule and determinants. How a computer solves systems of equations is they use Cramer's rule. They don't use elimination, they don't use substitution. It's faster for a computer, the number of computations it can do quickly, to use Cramer's rule. Okay? And Cramer's rule works off of determinants. By hand, it's a little bit more complicated than using elimination. Elimination is probably the easiest, or Gauss-Jordan. Gauss-Jordan back substitution is pretty quick as well. But we're going to talk today about determinants in Cramer's rule. Now, what a determinant is it's a value that you get. And it's, if you take a matrix algebra course, you'll talk all about determinants. You'll learn what they really are. But in this class, we basically just work them out. So we're going to talk about the determinant. And this is called the determinant, D. And I'm going to give you one. We're going to find it. Okay. D is going to be our determinant. And I'm going to have you find the determinant. Now, instead of having square brackets around it, it looks like absolute value bars. And I'll pick one of these from our textbook. We're going to do several of these 2x2s. I'll just pick some from our textbook to work through. Once we understand 2x2s, then we'll talk about Cramer's rule, and then we'll talk about 3x3s. So I'll just pick one of these to look at. And we're going to find our D here. And this is actually page 67. We're going to look at question number 7. And we're going to find this determinant. So we've got minus 5. 9, 4, and negative 1. And this is called a determinant. Now, what we do for these determinants is we multiply on the diagonals and subtract. So when it's 2 by 2, we multiply on the diagonal and subtract. So we have a negative 5, right, times a negative 1 here. And then we have a minus, because you always put a minus in the middle. 4 times 9. And determinants come out to be a number. And if you take a matrix algebra or a linear algebra course, you'll talk about all the theory behind determinants, how they were created, and what they are. In this course, though, I'm just giving you a quick overview of them. We're just going to use them so we can use and solve with Cramer's rule. But there's a whole course and nothing but determinants and matrix algebra and inverses, things that we don't cover. Now, when we multiply this out, we have negative 5 times a negative 1. It makes it 5. 4 times 9 is a 36. And 5 minus 36, well, that makes that now a what? Minus 31, and that's your solution. Yep, that's it. These are determinants. When we do 3 by 3s, it's a much different process. It's much more difficult. Let's do 9. We're going to do question 9 next. Same thing. Find the determinant. For question 9, we have, and these look like absolute values, but they're not. These are called determinants. And you always get them just by cross multiplying and subtracting. And we just draw the arrows, and we have to subtract between them. So write it out. And once you get good at these, you can do these mentally. So when I write it out, I have minus 1 times 3 minus, because you always have the minus there, 5 times a negative 2. So minus 1 times minus 1 times 3, that makes it a minus 3. And over here we have 5 times a negative 2, that's a negative 10, plus a negative out in front that makes it a positive 10, and minus 3 plus 10 that makes it a 7. So that determinant, sorry about that, would be a 7. Let's do one more, and then we'll talk about Cramer's rule and how it works. How about question 14? They're all pretty much the same. We're going to find the determinant. Yep, same page. These are still on page 567. Okay, and 14. So 14, again, and usually we call this D for determinant. But there's also dx, which we'll discuss that in just a moment. Now, 14, we have a minus 9. We have a 7, 2, and a 6. And we cross multiply here. So when I write this out, let's see what we've got. And take your time, minus 9 times 6 minus 2 times 7. Be very careful with negatives. It's so easy to make a mistake with these. Negative 9 times positive 6, that's a minus 54. 2 times 7, that's a 14, so it's a minus 14, because it's negative. We add these together, and we end up now with a negative 68, isn't it? Now we're going to use what we've just learned about determinants to solve a system with what's called Cramer's rule. And this is how a computer would solve a system of equation. Now, these are used in a lot of different applications. We only have usually 2, maybe 3 variables at the most. But in a real-world scenario, there might be hundreds of variables, right? Because if a company is working with things, it might be what goes into the price of a good. Well, there could be all these different things that go into the price of an item. How much we paid for the item, how many hours of work is involved, how far is it to drive the item to the store. All these things go into a factor. And so there might be 100 things going on or more, and a computer would be able to process it and come up with the best case scenario. That's called linear programming, and if you take a course in matrix algebra or linear algebra, you'll learn lots more about matrices and determinants and also linear programming. But here's what Cramer's rule says. I do what now? It just takes time. It's what we just did. To solve it, we're going to have to do it 3 times. So there's 3 determinants involved. And Cramer's rule says this, and this is actually on page 565. Okay, and this is Cramer's rule. Now, I explain it a little bit differently than how the textbook does it. But for Cramer's rule, we have this. Okay, we have to do these determinants. And it's kind of like what we just did with Gauss-Jordan, the way we line them up. We have what's called our master determinant D, and this is the x and the y. We have dx, which is what's on the equal sign, on the right-hand side, and then the y for the values. And then dy is the x, and the y becomes the equal sign. And x is dx over d, and y is dy over d. The textbook explains it in a little bit more detail, and they use matrix notation. I think it's more confusing. I think this is just the easier way to remember. When you look at d, you just plug in the x values and the y values from an equation. When we look at dx, we just replace the x with what's on the right-hand side, on the equal sign. Replace it. dy, same thing. So now we're going to be using Cramer's rule to solve a system. This is just a different way of solving a system of equations. And I'm going to pick one from our textbook to look at. We'll start off with a pretty easy one, 64, on page 569. Question 64. And we're going to solve this with Cramer's rule. Okay, so this is question 64, and we've got 3x plus 2y equals a negative 4, and we've got 2x minus y equals a minus 5. Now, when we talk about this is again a system of equations. There are multiple different ways of solving it. You can use substitution, you can use elimination, you can use Gauss-Jordan, and we're going to learn today about how to use Cramer's rule. They all give you the same solution, the same answer. Now, depending upon how the equation is set up, one method might be a lot easier to use than the other, but I'm showing you all 4 methods: substitution, elimination, Cramer's rule, and Gauss-Jordan. Now, for Cramer's rule, we use the determinants. So we have to come up with our 3 determinants, and we do each one of them. So we have to have 3 determinants to get our solution. We start off with our what I call the master determinant D. Okay, and D is the x and the y. So what values would go in here? Well, it looks like it's going to be a 3 and a 2 for the x, like looking down. And then we have a 2 and we have a what? Negative 1. So we can find this determinant. We'll do each one and then we'll put them together. So I can quickly multiply here. 3 times a negative 1, that's a negative 3. Then we have to subtract them. And we have a minus 2 times 2, And so that gives you a minus 3, minus 4. And so that determinant comes out to be a minus 7. Now we do the next one. So we need to do dx. And dx, whatever variable's down below, the subscript, gets replaced with an equals. So for dx, we replace the x with an equals and we plug in the values for y. So what's on the other side of the equal bar? Minus 4 and minus 5. What's my y values? And minus 1. Now calculate that determinant out. Yep, do the same thing that we just did. So that is minus 4 times a minus 1 minus, and watch all of your negatives, so you always have to subtract it off, a minus 5 times 2. Now when I work it out, what does that give you? Well, negative 4 times negative 1. Negative and negative makes it a positive 4. Okay, over here we have 5 times 2. It's a negative, so that's a negative 10. But we have a negative here, so that makes it a positive 10. Putting them together, what do we get? 14. Now we can go ahead and find our x. All right? Because what is x? Well, x is dx over d. Now, what did we find dx to be? Well, that was d, right? dx was the 14. D down below is a what? Minus 7. And 14 divided by a minus 7 is a what? Minus 2. Okay, that's one piece of it. So we have the x already. Now, what else do we have to find? Y. And as you can tell, elimination, and even probably Gauss-Jordan, is a little bit quicker. dy. Okay, dy is x, and we replace the y with what's on the equal sign. So let's go back up and look. What's my x? 3 and 2. So that's going here. And what goes on the equal sign? What's on the equal sign? Minus 5. Okay, and I know it's hard to keep all this on the same page. So that's going to be a minus 4 and a minus 5. Cross multiply, get your determinant. So that's 3 times a negative 5 minus 2 times a minus 4. 3 times a minus 5, that's a minus 15. 2 times a negative 4, that's a negative 8, but there's a negative in front of that, so that makes it a positive 8. Be very, very careful with your signs. And minus 15 plus 8, that makes it a minus 7. So what is y going to be? Well, y is dy over d. And we found dy to be a minus 7. And what was d? Minus 7. So when we divide them out, what do we get? 1. What is my answer now as an ordered pair? My answer is, yep, minus 2, positive 1. Okay? And that's your answer. Yep. And you could have solved it with elimination or substitution, and you would have gotten the same answer of minus 2, 1. Right? If you go on in mathematics, you'll be focusing a lot on matrix algebra because it's very important, and you're going to learn all kinds of different techniques, when to use what technique, how they came about. In this class, we don't have time to really go through all the theory. I just show you how to use it. But if you go on, you're going to learn about linear programming. You're going to learn all the things about matrix and linear algebra and how they actually are used and how they are applied. Now, these have been 2 by 2. I think we'll do one more of these, and then we'll look at 3 by 3. With determinants. And they're a lot more complicated. They take a lot more time to go through. So let's do one more, and then we'll talk about one that doesn't work at Cramer's rule, and then we'll look at 3 by 3. So let's look at 68. So we've got 3x plus 2y equals a negative 4. And we've got 5x minus y equals 2. Okay, so same process. We're going to solve with Cramer's rule. Now, we still got to get our 3 determinants. We always start off with D. And that determinant D is x and y. So we plug it in. So the x and y, we plug it in. That would be a 3 and a 5, 2, and a minus 1, right? Okay. Same procedure, cross multiply. 3 times a minus 1 minus 5 times 2. So 3 times a minus 1, that's a minus 3. 5 times 2 is 10. Minus this in front, so it makes it a minus 10. Plugging those back together. Okay, make sure we don't make any mistakes. Everything looks right so far. That gives you a minus what? Minus 13, isn't it? Because 3 times a minus 1 is a minus 3. 5 times 2 is 10. Change your sign. dx. Okay, so what is dx? Well, dx, we replace the dx with the equal sign. And we need to still plug in our y. That's the pattern. The textbook has used all those coefficients with the indexes. I think it's way confusing. This is just how I remember. The equal sign goes here, and the y goes there. So let's look and see what we've got. The x is getting replaced, so that's a minus 4 and a positive 2. Be very, very careful with your signs. Now, y, what is it? 2 and a minus 1. Cross multiply. So we have minus 4 times a minus 1 minus 2 times a 2. Minus 4 times minus 1, negative and negative makes it a what? Positive. Okay, so there's that piece. Multiply here, it gives you a minus 4. Those go together, and that gives you then a what? That gives you a 0. Okay? And we can now find x because what is x? Okay? dx over d, and dx is a 0 over minus 13. Well, that came out to be what? 0. Now, when you work these out, you're not going to get a whole bunch of fractions. If you end up with some fractions at the end, you made a mistake. All of these that I picked are whole numbers. Now, if you were working with this with an application, you might get fractions and decimals. But in the ones I've given you, no. They should come out to be whole numbers. So if you start getting fractions at the end, or a whole bunch of decimals when you divide, you made a mistake. Now, what do we still have to find? dy. And what is dy? Okay, dy is x, and then we replace y with what? The equals, because this y gets replaced with the equals. So when I go back and look, let's fill it in here. We're going to fill in our pieces. So that is 3 and 5 looking down. We replace the y with minus 4 and what? Positive 2. Now use the cross multiplication technique again to find these determinants. And that is 3 times 2 minus 5 times a minus 4. Well, 3 times 2, that's a 6. Double negative makes it a positive. 5 times 4, that's a 20. When I put them together, that gives you a 26. Now, we know we did it correctly because y is dy over d. dy is a 26. d is a 13. And that comes out to give you a 2. Let's see, did I miss a sign somewhere? Oh, yep, 13 should be negative. Should be negative 2. Okay, so is everyone all right with that? Now, what would the answer look like as an ordered pair? As an ordered pair, it is going to be 0, which was my x here, right? Comma, minus 2. You can't always use Cramer's rule. Cramer's rule does not work when d is 0. So if your d comes out to be 0, you're going to have to try another method. And I'm going to show you one of these here in just a moment. So Cramer's rule only works when d is not 0. Okay, if d comes out to be 0, it doesn't work. And it's either an infinite number of solutions or no solution, because you cannot divide by 0. Right? When you look here, when you solve for y, that's dy over d, right? And if d was 0, that's a number divided by 0, and you cannot do it. So if d is equal to 0, Cramer's rule won't work. So Cramer's rule only works when d does not equal 0. If it equals 0, then you've got to solve it a different way. Question 70. Question 70, we're not going to be able to solve this with Cramer's rule. Okay, Cramer's rule doesn't work for inconsistent systems and dependent equations. And we talked about those last time. Remember, inconsistent means it has no solution. So let's try to find our d. We're going to try to work with Cramer's rule, but again, if d comes out to be 0, we cannot use Cramer's rule. We've got to use elimination or substitution or even Gauss-Jordan. So let's plug in our values and see what we've got. We've got 12, 1.5, we've got 8, and we've got 1. So when I cross multiply, that's 12 times 1 minus 1.5 times 8. Well, 12 times 1 is 12. 1.5 times 8, that's also 12. And when I put those together, what do I get? 0. So when it's 0, that tells you that Cramer's rule, won't work. Cramer's rule won't work. And that tells you also it's either going to have an infinite number of solutions or it's going to have no solution. So let's now solve this and see what happens. We have to solve it by a different method. So Cramer's rule won't work, so solve it with elimination. So we've got 12 plus 8y equals 3. And 1.5, and this is x here, 1.5x plus y equals 0.9. Well, what's going to happen if I try and solve this with elimination? It's going to be a false solution. When that determinant d is 0, it either has an infinite number of solutions or no solution and is inconsistent. So how would I solve this with elimination? If I want to eliminate for the y, which is probably the easiest, what would you multiply the second equation by to get rid of the y? Minus 8. And what's going to happen when I do that? When I do that, I get 12x plus 8y equals 3. That stays the same. Negative 8 times 1.5, well, that is use a calculator, negative 12x, isn't it? Negative 8 times y, that's a negative 8. And negative 8 times 0.9, that's a minus 7.2. Now, what happens when I add down again? We talked about these last time. It gives you 0 equals, what, a minus, well, we got 3 minus 7.2. It should come out to be a minus 4.2, isn't it? And does 0 equal minus 4.2? No. So this is inconsistent system and no solution. Which one here? Sorry, that should be a 12. Yep. Sorry about that. There was a little bit, it looked like a decimal point there. It wasn't. It was just supposed to be 12. Sorry about that. Okay. But why does Cramer's rule not work? Because it's an inconsistent system. Now, it would be the same thing if you had an infinite number of solutions, because your D would still be 0 again. So if your D comes out to be 0, then solve it with elimination, and it'll either be infinite number of solutions, dependent equations, and we did some of those. We solve it and get the variable y by itself. Or it'll be like this, where it has no solution. So Cramer's rule does have its limitations. Now, so far, we have only worked with determinants that have 2 rows and 2 columns. When we start getting anything larger than 2 by 2, when we start looking at 3 by 3, or even 4 by 4, the amount of work is dramatically increased. It's a lot more work to do a 3 by 3. Now, when we do 3 by 3 determinants, we have to use cofactor expansion. I think that's the easiest way to work them out. We're going to have to find out the 3 matrices, determine the determinants of each one, and put them together. So we're going to now look at a determinant that has 3 rows, 3 columns. So we'll look at, how about page 567. We're going to look at question, let's look at one that's going to be pretty easy to work through, 25. This one doesn't have a lot of zeros. I want to do one that doesn't have a lot of zeros first. And then we'll go from there. These take time to go through. And there's no easy way to really work them out. They're like the systems when we used elimination. It's not really hard. It just takes a long time to actually do. Minus 3, 8, and 10. Let me make sure I copied it down correctly. Now we're going to find this determinant. That's what we're going to have to do. Now, when we look at this determinant, it's 3 rows by 3 columns. What we have to do is split it up into 2 by 2s. But that means we're going to have to do 3 2 by 2s to get that to come out. We're going to either expand across the top or expand down the side. Now, normally we just expand down the side, but if you have a lot of zeros, you can expand different ways. And you can even create zeros. And again, if you take a linear algebra course, you'll learn all kinds of different techniques and shortcuts for solving these. We have to do what's called cofactor expansion. And the signs go plus, minus, plus. Or plus, minus, plus, depending upon which way you go. I'm just going to expand down the side. So we're going to start off with our 10. Now we have to get 3 of these matrices, 3 of these determinants to do. So we're going to end up with 3 of the 2 by 2s. So we start off with our 10. And now, how we create our 2 by 2 is we cross it off. So I take my 10 and I cross it off vertically, and I cross it off horizontally. You just cross it out, cross it up, cross it down. Just draw lines through it. And what's my determinant that's left over? 4, 3, and 8, what? 10. So that's the first one. How we do the next one? Okay, what's the sign of the next one? Negative. And we're going to go down. We can go across. It doesn't matter. It's all the same. You either go down or you go across. The next number, we've got our sign that's a negative, and it's a negative 1. Because they always change back and forth. So plus, minus, plus. Or plus, minus, plus. They always switch back and forth. It's just how matrices work. And determinants. So that's minus 1 here. We've got a minus in front. Now, cross it out again. If I cross it out here, draw your lines through there. I don't want to draw lines because then we lose the matrix. But if I form them here, what's left over? 2, 1, and 8, what? 8, 10. And the last one, we have a plus. And this is called cofactor expansion. So if I cross out that last one, that number was a negative 3. And what's my determinant going to be? 2, 1, and 4, 3, isn't it? Okay, now is everyone okay with how I got those? We're going to do a couple of these, and we may or may not have time to use Cramer's rule on these, because Cramer's rule, you saw how much work it was when you had 2 by 2, and 3 by 3, it becomes substantially more work. It's not hard, it just takes time. Okay, so let's go ahead and work these out. We're going to do each one individually again. Now we broke that 3 by 3 up into 2 by 2, so we can quickly just use cross multiplication. So we have 10, and we have 4 times 10, right? Minus 8 times 3. Let's just do one at a time here. So 4 times 10, that is 40. 8 times 3, it's a negative, so 8 times 3 is a 24. 40 minus 24 is 16. And 16 times 10 is 160. So there's that piece. Okay, we're going to do each one of them individually. So 4 times 10 is 40. 8 times 3 is 24. Subtract them, you get the 16. We still have the 10 out in front. Next one. What do we know about the next one? Well, the double negative in front of that 1 is going to make it a positive 1. You don't even have to write it, but I'm going to, just so you see it's there. And what would it look like? 2 times 10, right? Minus 8 times 1. So that is 2 times 10 is 20. Minus 8. 20 minus 8. Minus 16, right? Oh, sorry, minus 12, I mean. Why did I say minus 16? Minus 12 there. And minus 12 times 1 makes it a minus 12. So there's that piece. And it just takes time. Wait, it should be positive 12. Sorry about that. And like I say, be very careful with the signs here. It is so easy to make a sign error. Now we do the last one, and then we put them all together, and that gives us our determinant. So for the last one, positive and negative keeps it a negative 3 there. And what's it going to look like? 2 times 3 minus 4 times 1, right? Remember how we do it? Two times 3 is a 6. 4 times 1, that makes it 4. We still have the minus there. 6 minus 4, that's a 2. 2 times a negative 3 makes it a what? Negative 6, doesn't it? Add them across, and what's my determinant? Yep. Okay, add those together, which is 160 plus 12 minus 6 And so that gives you then what? 166. Yep, because 160 plus 12 minus 6. Yep, that does come out to be 166. Yep, and that's your answer. That's the determinant. Okay, now look at how much work that was for a 3 by 3. Now 4 by 4, what would you have to do? I'm not giving you any 4 by 4s, but 4 by 4, you would have to take the 4 by 4, make it into a 3 by 3, all those 4 3 by 3s, and then do each 3 by 3 just like this. That's how they become so much work, and that's why anything past about 3 variables, 3 equations, you use a computer. Because anything more than that is just not viable to do that by hand. It just takes too long and it's too complicated. Okay, so let's do another one. One more. And we'll see how much time we have left. But we may not be able to get to the Cramer's rule for the 3 variables today. We may have to do that on Tuesday. But I want to do one more determinant. How about we look at question 30? We've got 5 minus 3. We've got 2. We've got a minus 5. 3. Minus 2. 1, 0, and 1. And again, we want to find the determinant. We're going to try to find this determinant. And you can go however you want to go. On whichever way you want to go, you just either go rows, columns, however you want to pick the 3. It doesn't matter. You just have to come up with the 3 small determinants to put together. And we can even go across the bottom if you want to. That would be the easiest way, but we'll just go down the side. Because you may not see all the tricks that are involved. So let's just go down the side. Remember, how do they go? Plus, minus, plus. So 5. That gets written here. And what does it look like for my determinant that's left over? Yep, okay. 3 minus 2, 0, and 1. And then we've got the next one. Remember, your next sign is negative. And what's my next number here? Negative 5. So watch out. It has to have that double negative there. So you've got to be very careful with those. You'll lose the sign if you're not careful. Yeah, because these signs on the side are always there. It's plus, minus, plus. And so that's like when you subtracted it off. Remember, we had to subtract them. That's the same thing here. It's just taking this 3 by 3, making it into 3 smaller 2 by 2s that we can then do. There's other tricks where you can write them on the side and just do the diagonal. I think that's more confusing. And it doesn't work anything bigger than 3, so I don't have you do it. Okay, let's go ahead and cross it out and see what we get for our determinant here. It looks like it's minus 3, 2, and 0, 1. And the last one is 1, right? And minus 3, 2. And 0, 1, isn't it? Yep. Oh, wait, not 0, 1. What am I doing? Sorry about that. I crossed off the wrong one. Yeah, it's going to be 3. Sorry about that. I just crossed off the wrong one. And a minus 2. My mistake. Okay. So there we go. And in a moment, I think we have enough time. I'll work this one again, but I'll show you how an easier way would have been to go across the bottom. And I'll show you that you're going to get the same result in just a moment. Let's go ahead and work this one out. Okay, and see what we get for our determinant. And then I'll work it again, but I'm going to go across the bottom. So let's work this out. We've got 5, okay, and that's going to be 3 times 1 minus 0 times a minus 2. Well, 3 times 1 is 3. Zero's gone. So that one comes out to be 15, isn't it? Next one, double negative, makes it positive 5. And we've got that 0 again. So that's going to be a minus 3 times 1 minus 0 times 2. That piece is gone. So that's 5 times a negative 3, and that is a negative 15, isn't it? And once you get the hang of these, they go a lot faster. It doesn't take that long, and you can even do these all mentally. Like you do enough of them, you can just almost do it mentally in your mind. The next one, we've got the 1 out in front, and that's going to be a minus 3 times 2 minus, watch your signs here, 3 times 2. Minus 3 times 2, that's a minus 6. 3 times 2 is a minus 6. And be careful because that gives you a minus what? 12, doesn't it? Right? Oh, did I make a mistake here? Yep. Sorry about that. I was doing good this morning, but I made a mistake here. So that's going to make that then what? That's going to make that then 0, isn't it? Yep. Sorry about that. Be very, very careful with your signs. And I just got in a hurry. That was my mistake. So what is your determinant then? Yep. Uh-huh. Okay, which step are we looking at? Did I make a mistake in the very first one? Hopefully I didn't. I got it. I wrote it down all right. Yes, we got the correct answer, which is 0. So which step are we looking at? Okay, this one. Did I write it down wrong? Okay, let's go through each one individually again so we can talk about it. If I pick the 5, okay, if I pick the 5, then what is my matrix going to be? 3 minus 2, right? And 0, 1. That's that. Okay? Then we do the 5 minus 5 in the middle. Now, don't forget, there's always a negative that goes with that one. So there's a negative of the negative 5. And what numbers are we left with here? Minus 3, 2, 0, 1. And then we do the last one, which is here. Okay, and it's going to have a 1 in front. Oops. Right, so we keep it so we can see it. And what would it be? Minus 3, 2, 3 minus 2. Okay, now this one we worked out correctly. Is everyone okay with how I got the 15 here? Does that make sense? Well, let's look and see. Here?
No, on this last one, right?
This one? Oh, okay, so this one's 15. We know we did it correctly. Right? That one's correct at minus 15. Let's look at this one. Minus 3, right? Times minus 2. Negative and negative makes it a positive 6 there, right? And then this side we have the negative. Don't forget about the negative here. 3 times the 2. That makes that a negative 6, doesn't it? So that makes that then a 0. Does that make sense now? Do we see the signs? Okay. Sure. Okay. It's just the signs. I know it's confusing because the numbers are the same, and that's why it's mixing you up. Okay. Let's take our time here. The 1. The 1 is here. Okay? Now, what do we have inside? We have a minus 3 times a minus 2. Okay? Yes, that's what, remember, we go on the diagonal. So minus 3 times a minus 2. Minus 3 times a minus 2, well, a negative and a negative makes it a positive 6. Are we okay with that now? Then we go up. Now, when we go up, we always have to bring down a what? Negative. And what's across on this diagonal? 3 times the 2, right? So that's 3 times 2. Now, negative 3 and negative 2, you told me that was a positive 6. And 3 times 2 is 6, but what's in front of it? The negative. And then 6 minus 6 makes it then a what? 0. And when I put them all together, then what do I get? 0. Does it make sense now? It is just so easy to make one little sign error. You could have expanded a different way and got the same result. I'm going to do the same question again, but I'm going to expand across the bottom with that 0, and you're going to see how much easier it is to do. You can go across the top, across the side, down the middle, whatever you want to do. You're going to end up with the same result. Now, again, I'm going to go across the bottom. Plus, minus, plus. Okay, so let's get the same result, same determinant. You're going to get the same result. A lot less work this way, though. So let's expand across the bottom. Okay, if I expand across the bottom, okay, what is that? That is 1 times the determinant. Yep, 2, 3, and negative 2. Now the next one, if I'm going across the bottom, I'm going to the 0. We'll get that determinant, but we don't have to worry about it. Why not? Because it's being multiplied by what? 0, right? Do we see where that came from? And that's going to be 5 and minus 5, 2, and negative 2. But we don't even have to worry about this one. Why not? Because it's getting multiplied by 0, isn't it? Right? So it's gone. We don't have to deal with it. It should be a minus, but 0 doesn't even have a sign. I should have put the minus there, but 0 doesn't even have a sign, does it? So it doesn't really matter. But yeah, it should technically be a minus, but minus 0 is the same thing as plus. What about the last one? Now look at how much easier this is because these have just 1s in front. And what would it be? It would be 1 times 5 minus 3 minus 5 positive 3, right? Now we don't even have to do the middle determinant. Why not? Because it's getting multiplied by 0. Whenever you have zeros, that makes it easier. And you can even manipulate things around to make more zeros. But we're not really going to learn how to do that because that's a more advanced course. But again, there are entire courses which are nothing but techniques for solving these systems. So let's go ahead and work this out. Now, I'm not even going to worry about the 1 because 1 times anything is just itself. So what would this one be? Okay, this one would be, working out this determinant, minus 3 times minus 2, right? Minus 3 times 2. That is then 6, right? Minus 6, which is then what? 0. Now look at this one over here. This one doesn't matter because it's gone. What about this one over here? Well, this one would be 5 times 3 minus a minus 5 times a minus 3. And 5 times 3 is 15, but look at this one. A triple negative keeps it what? Negative. 5 times 3 is 15, and so that also makes it what? 0. So what is your determinant again? So it doesn't matter how you do it, and you can even go down the middle, you can go across the middle, you can even go on the diagonal. There's different ways of doing it, and you want to try to find those zeros. Or just work it out the same way every time, just go down the side. Now, next class period, we're going to finish up 5-3, because we're going to learn how to do Cramer's rule when you have 3 variables, which is 4 of these to work through. Okay, so what's our homework for next time? Let's talk about our homework, just so we know what our homework is. So just so you know what we're going to be covering and what you need to do, we did 5.1 and 5.2. You should be able to now do them all. 5.3, we can do most of them, but there's only a couple of them that you can't do yet. And we'll cover those next time, and you can do them all but 5 and 9. So do them all but 5 and 9, and I'll pick that homework up on Thursday. I do what now? On 8 and 9, you mean? Why did I say 5? Oh, sorry about that. I don't know why I said 5. It should be 8 and 9. My mistake. 8 and 9. Okay, 8 and 9. Stop thinking. 8 and 9 you can't do yet. In 5.3, you can't do 8 and 9 yet. You can do all the others, but 8 and 9, these have 3 variables. Now, you can do it if you want to read ahead and see, but it's 4 of those 3 by 3s. Is what it is. It's the same process as what we did with the 2 by 2s, but you have to do 4 of the 3 by 3s. So I'll pick up the homework next time, on Thursday. Yep, and there's a sign-in sheet that I've got right here. I just signed the sign-in sheet. And some of you may have some old homework to pick up as well. So I'll put the old homework over here. And if you've got late homework you want me to pick up and grade, you can pick that up as well. And graded homework is going to be over here. All right. Thank you very much. Your name's on here. Get it graded. All right. I don't think you have any homework. I think it's all been picked up. You might check and make sure. And, yep, sign-in sheet should be around here somewhere, so make sure you sign the sign-in sheet. Who's got the sign-in sheet? I finished. Finish that, Chris? All right. All right. Finish all of that one. Okay. Is it all done? Okay. I was going to say, turn in next time if you want. Doesn't matter to me. You finished with it? Yeah, I'll grade it for you then. Oh, yep. Thank you very much. Sign-in sheet's going to be up here. And so I will see everyone then on next Tuesday. So next Tuesday we're going to finish up 5.3, and we'll start reviewing for our final exam.
This guy he traveled, he's in France.
Yeah, that's okay. I just put it back in the pile. Several of them are already gone.
Yeah. He's already done?
Yeah, half the class already left early. I have to go back. Same thing with Yep. I know who's got everything done. So there's a lot of students that left early just because it's.
You came.
Yeah, don't forget to pick up your own homework. Should be 2 of them over there too. There's yours. And you got yours? Okay. Yeah. All right. You guys have a great rest of your day.
You too.
We'll see everyone on Tuesday.
Have a great day.
Hey, yeah, you too.
See you, boys.
Did you have a question? Yes. And then the take-home one is behind you.
This is final.
That's the take-home one. And then you'll have one in class on that Thursday. On the 15th, I believe. Yeah, you'll turn this in on the last day of class. On the final. This helps you get ready for the final. So this is going to look just like your final exam. Okay, very, very simple. And we're going to start going over some of this on Tuesday and Thursday. Okay? You're welcome. You guys have a great rest of your day. Uh-huh.